Hello friends, how are you? I hope you all are well. This video is just extension of my previous video where I explained electric field intensity at a point due to field charge. Electric field intensity at a point due to a point charge. But this is electric field intensity due to a continuous charge distribution. When I explain electric field intensity at a point due to a point charge, I might have said like this. Suppose this is the plus Q charge. Here is a point P. I want to find the electric field at this point. Electric field intensity at this point. The formula what I used, it might be E is equal to Q upon 4 pi epsilon naught R square. Okay. Here the epsilon naught indicates that the point where I calculated the field intensity is in free space. Okay, and the charge present is here. It was the small q, but in this case I can't use this formula directly. And one important fact is that in our practice, in our practical life, we don't face point charges generally, we face the charged body. If it is a charged body, then the charge distribution may be linear charge distribution. It may be linear charge distribution. It may be area charge distribution. It may be volume charge distribution. Then how will calculate the electric field due to a continuous charge distribution? Let us see. For example, here dq is a small element of charge. dq, small element of charge. At this point P, which is at a distance r unit, I want to find the electric field intensity. Then I can say that due to the small element of charge, the electric field intensity, which will be very small, is equal to dq upon 4 pi epsilon naught r square. Okay. Here dq stands for the small charge, small element of charge. R is the distance, this R stands for the unit vector. If I want to calculate net electric field intensity, that means I have to take the integration of this d, then how it will be? It will be 1 upon 4 pi epsilon naught dq upon r square. Okay, because this is a universal constant, so we have to take the integration of this factor dq by r square. So this is about the electric field intensity due to a continuous charge distribution. But the charge distribution may be linear, may be area distribution, means superficial distribution, may be volumetric distribution. Okay, so for linear charge distribution, listen carefully. for linear charge distribution. See that. Suppose this is a wire. Its length is L. The charges are distributed uniformly. Now I shall consider one small element. Its length is dl. The charge I shall consider that is dq. Then we know that dq is equal to lambda into dl. What is this lambda? This is the linear charge density. I can say this is linear charge density. Linear charge density means charge per unit length. Charge per unit length. Then I can apply that formula due to point charges. Now what I shall write? Now I can write that this electric field intensity is equal to 1 upon 4 pi epsilon naught dq upon r square is equal to 1 upon 4 pi epsilon naught. In place of dq I can write lambda into dl upon r square. Okay, this is the field intensity due to a continuous linear charge distribution. This total length I have taken L. Small element of length I have taken dl, and here dq is equal to lambda into dl because previously I explained this charge is directly proportional to length. Okay, so what about for area charge distribution? For area charge distribution. For area charge distribution, what I can say? Suppose we have taken some area where the charges are distributed uniformly. From that I shall take a small area. Suppose that surface area is ds. So in that case I can say that this electric field intensity 1 upon 4 pi epsilon naught. Here epsilon naught because we are considering in free space. Is it in place of lambda into dl? I shall use what I shall use? I shall use sigma into ds. dq is equal to sigma into ds, where sigma stands for area charge density, means charge per unit area. This is the area charge density. So I can say that this is sigma ds upon r square. Okay, this is for area charge distribution. What about for volume charge distribution? So for volume charge distribution, I can say that, see here, these charges are distributed throughout its volume. So I am taking one small place where the volume is dV. Then I can say that this electric field intensity is equal to 1 upon 4 pi epsilon naught. In place of a dq, I am going to use the rho into dv. So I can say that rho into dv upon r square. Okay, this is for volume charge distribution. At first I consider one small element of volume dv. Thereafter by integrating I got this fact. Okay, so this is for volume charge distribution. Okay, that means the charge is distributed throughout the volume. So this is about the how to calculate electric field intensity due to a continuous charge distribution. In my upcoming video, I shall explain about the electric field lines. Until then, bye.